Yeah. Okay.
Okay. Decorators. Yeah, so I've been going through this course on Udemy. It's like intermediate to advanced Python stuff. I got to a section like 2 or 3 months ago. Learned a whole bunch of stuff, and I'm gonna share it. Yeah, so I mean, basically, before then, if you asked me what a decorator is, I would have said the stuff with the @ symbol changes functions somehow. Hopefully, by the end of this, we'll have a better understanding of what they do. So first thing, decorator, it's the @ symbol. So first thing to get on the table is that is syntactic sugar. So if you have something, here, I'll just type out.
You make it a little bigger. And yeah,
yes.
control plus. Good old electron.
Good. More.
Yeah, that's better.
All right. So if you have some kind of decorated function, and return hello. So doing this is exactly the same as defining a function and then reassigning this variable to decorator of my func. This, and this are doing the exact same thing. If we go into whatever, I'm just opening like somewhere where we're using decorators. Sure, this.
High order.
Right. Doing this would be the exact same thing as defining the function and then putting this here, that equals PyTest fixture, blah, 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 of this. We can rewrite all the tests like this. It'll work. I tested it. It's exactly the same thing. So that's the first thing to understand. And I want to just go through a bunch of examples that'll put the rest of the picture together.
Decorator is a keyword in Python?
No, you can call it whatever. It's just the
whatever the function
yeah.
is. Oh, I see. Function that takes a function and returns.
Right. It's a function that takes a function and returns anything. So the first example I want to do is this is okay. That's not actual code. Second. So the first thing is I'm going to make a decorator that basically breaks a function to show that this is actually what happens. So we can. I'm going to write a decorator that takes a function, and anything that it decorates will just become none. So we can define nullify. That'll take a function, and it just returns none. So that's the decorator. And then if we define a function, whatever, say hello, that will print hello. Normally that would print hello, right? But if we decorate this with nullify, this will be the same thing as redefining say hello to whatever gets returned from noneify. So down here, this is going to break because say hello isn't a function anymore. It's just none. And if you print say hello, it's none. Okay. So that's just demonstrating what this syntax is doing. Moving on to the second example, simple decorator that doesn't actually do anything to a function. So instead of returning none, we can just return the function. I don't use Jupyter very often. Okay. We can have another decorator, don't change, that takes the function and returns the same function. And now if we have say hello again, we'll decorate it with don't change. It's not going to do anything. It's just returning the same function. So it's reassigning say hello to what gets returned from don't change, which is the same thing. So now over here, if we call say hello, it's just going to print. It's going to do the same thing. It's the same function. Is something wrong? And, oh, I'm not calling it. Okay, I just defined the function. And then if we call it, it prints hello. Okay, that's that. What if we want the decorator to actually do something? So this is the decorator right now. But what if we want to, before each time that the decorated function gets called, it's going to print the time and then call the function. So we want some kind of log time decorator that will, let's do this again, say hello, log time, print hello, and we want to do something in the decorator that'll print the time every time that say hello gets called. Anyone want to take a stab?
Print the time.
What?
Return.
Here? I mean, we'll import. No, from date time. From date time import.
I'm not going to only just print it the first time you wrap it.
Yep.
Just the same when it parses it.
Yeah. So date time dot now. Right. Right. So this is going to do the same thing as say hello, doing this, and then say hello equals log time of say hello. What gets returned from log time is just the same function. We're just going to print datetime.now here, but then when you call say hello again, it's just the same function that got returned.
So print date once.
Right.
It's not yeah.
What?
It's not
Oh yeah, sure.
So
so get rid of this.
Just do it a few times.
So this, right, when you define the function, it prints the time. And then when you call say hello, it's just going to do the same thing.
No time.
Right.
Return a new function.
Return a new function.
That prints the time.
Yes.
Then that's the function.
Yes. So inside of here, you make a new function that I haven't really found like standards on what to call these things inside of here.
Like underscore thing?
Yeah.
Yeah.
I don't know. I've seen deck. I've seen underscore. Whatever. Decorator.
And takes in
The decorator. This guy. You already have the function from here. But inside of this function, you can print that, then call the function, and then we're going to return deck over here.
Yep. And you want to return the function. And
You're returning. This is the function that you're returning.
No, but then you want to.
So now say hello.
No, but in deck, don't you want to return the call of func? So if func is returning something, it will go up as a return value. Right now, the return value from func will just get discarded.
Sure. Yeah. Okay. So yes. Right. So now deck is going to get returned. Say hello will now be deck, which calls print, which prints the time, and then calls what say hello used to be.
How would you do that with parameters?
Yeah, okay.
We'll get there. Okay, right. So now we redefine say hello with the decorator, and now if we call say hello, it does that. We can call it again if I find the box. There. So now the decorator is actually doing something. Right. We'll get to it. Okay, yeah. How do you deal with function parameters? If the decorated function is supposed to take something. So if we have copy this. Say hello takes a name. And we want to print hello name. So right now, I guess what's going to happen? If we do say hello like this, it's going to, you're not passing in a name. If you default name to none there.
Otherwise, it'll throw it.
Yeah. So name say hello is missing positional argument. It's not getting passed in here. Didn't pass in.
You both say hello and you turn on.
Oh, okay, right, yes. So, right, the same problem because, right, deck. Okay, that's the problem. Deck is getting called. Takes 0 positional arguments, but 1 was given. Why? Because
the function comes with the argument.
Because the function, right, now say hello is deck. We're passing the name into deck, which doesn't. So how do we fix this? Yeah. Right. So if you add star args, star kwargs into here, now it can decorate a function that takes parameters. And so now we decorate it again, and now over here, say hello is missing. Oh, because this, right, because these need to get passed in to here. Okay, now it works. Okay. That's how you get parameters into. That's how you decorate a function with arguments. Next, I'm going to go on a slight detour to show some weirdness that's going on in here and how to fix it. Right, say hello has been redefined to dec. So there's a bunch of stuff built into Python that you can like introspect the function. So say hello dot name right now. You expect it to be say hello, it's dec. What's the other thing? Inspect. Oh, okay. For inspect. And you can like print out what the function is. So we can print inspect get source of say hello printing dec. There's a decorator in the Func Tools module that fixes this. Import from Func Tools.
Programming tools.
Import rats.
Oh, now we know where rats come from.
So now if we do this again, wraps will wrap the function that's getting returned over here. This wraps the function that got passed into the decorator. And now this is, I don't know exactly how this works,
So
but it takes all that stuff from the function that was passed in and assigns it to the function that's getting returned from the decorator. And now, if we do this again, now if we do this again, now we have, this is the right thing, and the other one is also going to be right.
Wow.
Okay, that's rats. And it does. It does look like a decorator that takes an argument.
That's why it has to be used inside the decorator.
What?
That's why it has to be used inside of the decorator making the outside.
Which is, I'll use that as a segue to decorators that take arguments. Right, the log time was just log the time that it is now. We're not taking any arguments there. What if you want to write a decorator that takes an argument? What if you want to rerun the function? So it'll be a decorator that takes a number of times that you want to rerun it. And it'll, whenever you call the function, it'll run it that number of times. So right.
We have a Python plugin.
Right. So when you told me that, I'm like, oh wait,
That one throttles it a little bit better. Probably it probably takes some cases more edge cases, but
So if we have a decorator, we want in the function that's getting returned, we want to, it's not going to print the time, we want to run it for whatever, something in range runs, wherever that's going to come from. We're going to return, we're going to call the function that number of times. And in the decorator there, we're going to pass in whatever free. What do we do with this? How does the 3 get to runs?
it's the second argument and the top
Here?
The first one is that the syntactic sugar is passes the function as the first argument.
No, it's the only argument.
Oh, only argument.
So that's going to break.
You need to wrap it again. Yeah, rerun needs to be a function that returns a function that.
Yeah.
Oh, man.
So yeah, so if you want arguments, you need to make a decorator factory.
Decorator factory. That's cool.
So rerun is going to have whatever the decorator inside. I don't know what the name of the conventions are, but this is going to be the actual decorator. Rerun takes, so the actual decorator is where function gets passed in. Rerun is a factory that's going to take a number of reruns. Decorator returns. We'll rename this to underscore that.
Rename.
Oh yeah, right. Okay, whatever. Runs gets passed in here. That will return a decorator. That will run it that number of times.
That works.
And here you have to return deck.
That or does the at sign for them? You use at.
So this will do. So it's the same as
Evaluates that line.
say
and
hello
passes the function to whatever it is.
equals rerun this whole thing of say hello. The rerun of 3 is gonna return the decorator with runs set as 3, and then you're passing say hello into that decorator.
Rerun 3 returns a function that you're calling with the say hello argument.
Right. So let's get rid of this.
Okay, Ari, the at sign doesn't. I mean, how does that work? I thought that only works the thing that takes the function.
The
Did
at
they say
sign-
we use the
That's part of the syntactic.
I mean, it knows it can.
It'll evaluate that
it's
part.
calling
first.
it's calling whatever else is on this line, that whole thing, throwing another parentheses on and passing a function.
Does that mean that you could actually like have like just a print on an at and then it'll crash? Like at print hello, and then it'll crash with bad syntax, but it will print the hello.
Yeah, that should work. Yeah. Here. Print hello. Get rid of this.
No, I'm saying get rid of the function.
Yeah, that.
Okay. So it'll do whatever you want, basically. Okay.
What's the error? The error
The
is
error
It's not a function, so
It's
it
not a
can't take a
function,
function. Yeah.
Right. The same thing as the none thing.
Right. None type is not callable because it returns none. But if you, so you could have a lamb, but you could.
Where did that go? Okay, right. So now this is defined with the decorator. So if we call say hello like that, that is going to run 3 times. What did I do?
You need to pass a name into hello.
Need to pass a name. Oh, okay. Fine. Why? What did I do? Fine. What did I do? Print it's returning. That's the problem. Is that the problem?
No.
No.
It just returns a none. But
Oh, I have to print. No, is that? I have to print this.
no, it's gonna print.
Right.
It's gonna print.
Oh, that's right here. Rerun.
What are the 3 dots? The 3 dots. Is it collapsing the same output? No.
Is the wrap supposed to be on the outer deck?
No, it's wrapping whatever function is. No.
Okay. That's like run.
I just tried this and it was working. Reruns. Let's see if that's better.
It's not returning. It's just calling it to retry it. That return.
No, return
Rerun is taking runs. Runs gets passed in here for.
Yeah, because it's when you do
Yeah.
a loop, it's returning after the first iteration of the loop. Yeah.
Oh yeah. Okay. Yes. That was it. Okay. Fine. So we'll do it without returning that. For that. Now it'll play 3 times. Okay. Thank you. Okay. Yeah. So that's how decorators work. You can go further. You can. I mean, this was. You can normalization in here. You
Debalance anything higher order function.
throw in a cache here. You want to- It's going to be part. What's it called?
Closure.
Yeah,
It's wrapped in a closure.
it's going to be part of the function's closure. So anytime that it gets called again, it'll still have the cache. So cache, whatever equals func.
Properties work.
Cache properties work in a similar way, probably. Yes. Yeah, that's probably exactly. Except they time the thing as cache.
Right.
And settings and things also.
So now if we had a cache in here, and on each of these, it's going to add it to the cache and then print the cache. I mean, it's going to be hello each time, but just to show what's going on. It's adding it to the cache each time. But now if we do this again, the cache is still going to be there. But from the beginning, the cache is still there.
No.
That is...
Because it's instantiated with a function.
It's the closure is with the function itself.
Right, yeah. Yeah, so that's decorators. Somewhere in here we have a reps. And you want to look through this and understand what's going on a little better?
Yeah. Awesome. All right, thank you, Ari.
You are.
All right. I'm going to throw one addendum on this. Django, prior to class-based views, function-based views, which they have not removed because they still do things that function-based views can't, that class-based views can't do. But function-based views, they assume you're going to use a decorator pattern. So right now, when you have your class-based view, you mix in, login required and this required and that required, and you basically mix in a whole bunch of stuff, and you get your class with the behavior you want. Detail view, message, error, redirect on success, error, all that stuff. You can just mix in behaviors. They have a lot of that stuff in decorator patterns. So you just make your little view function, and then you just decorate it with everything you want, and then you just look at it, and that's the checklist of the behavior. That pattern is mirrored very similarly in the library Recompose that I've mentioned previously, and the React thing I mentioned it. And it's just really good to understand how that kind of function composition works. So then why would you go to object-oriented class-based views? And the answer to that is that Python, even though they're very heavy on class-based views should be used via composition or mix-ins, which is how Python really all kinds of weirdo things you don't have in C with actual inheritance. So I think that's why they went in that direction, because they're not sacrificing, the software composition.
And how does it work with multiple decorators?
Because the decorator just takes
when you have two decorators on.
I'm not sure which order it goes in.
Ordering matters,
Yeah.
but it's function composition. When you have that compose function that you just pass in a whole bunch of functions in a row, and then as long as the inputs of each one match the outputs of the next one, you can compose as many as you want. This is Python's nice way to do function composition. So
one decorator will take in the function, return a new function, that'll get thrown into the next one, I'm not sure if it goes top to bottom or bottom to top.
And that's why Python, Django says if you're using line required one, it has to be on the bottom of the list, on top of the list. And class-based views, when someone discusses MRU and whatever, Python nice inheritance stuff. So we're going to talk about that. Yeah. So then that's what you'll have to explain why the login required mixing has to be first. And are there any that have to go left? I don't know. But anyway, okay. Go ahead, you can handle the recording.
Sorry.
If you could post the notes.
How do I do this?
Record and transcribe. There we go. Awesome.